Hello, physical science students. Mrs. Smith here. Today we're going to be talking about specific gravity, which is one of the physical properties of a mineral that can be used to identify it. Now, today's pre-lab is going to give you the information you will need in order to be successful on Monday's lab. All right, directions. It says to watch the video posted on the classroom website, which is what you're doing right now, in order to take the notes before. The entire pre-lab must be completed by the due date in order to participate in the lab. So today we're going to go through the pre-lab, which is just this front side. You're going to bring it back on the due date, and we will be able to do the actual lab during class. So our first question here is, what is specific gravity? Now, we already talked about this a little bit when we learned about the physical properties of a mineral. So let's review. Specific gravity is the ratio between the density of a substance and the density of an equal amount of water. We know specific gravity is a physical property because we don't need to perform any type of chemical reaction in order to observe it. Just a simple test of finding mass and volume is enough to figure out the specific gravity. And we know it can help us identify a mineral. How so? Let's look at number 3. Each mineral has its own specific gravity. For example, the specific gravity of the mineral talc, remember that was that mineral with the hardness of 1 that can kind of crumble in your hand, is 2.7. Whether the sample of talc is large or small, its specific gravity will still be 2.7. However, the mineral calcite also has a specific gravity of 2.7. Therefore, each mineral substance has a distinct specific gravity that will not change under normal conditions, but there may be multiple minerals that could have the same specific gravity. So for example, what we're going to be looking at later is this mineral chart right here, and this data table is showing metallic minerals. And if you look, there is a column for specific gravity. For example, we can see that graphite has a specific gravity of 2.3, magnetite, which is magnetic, has a specific gravity of 5.2, cinnabar, that was that red one we saw earlier, has a specific gravity of 8.1. So as you can see, different minerals have different specific gravities, and it's one of the ways that we can identify it, along with its cleavage pattern, its streak left behind, its hardness, and other special properties. All right, our next question is, how do you calculate specific gravity? It's almost like calculating density with one little twist. So the specific gravity is going to equal the density of a mineral in grams per milliliter as our units, divided by the density of water, also in grams per milliliter. If you remember from our previous unit, to calculate density, we do the mass of the sample divided by the volume of the sample. And also remember that the density of water is 1.0 grams per milliliter. So in essence, we are going to calculate the density of the mineral sample, and then we're going to divide it by 1 gram per milliliter. What you should note is if you have grams per mill on the top and the bottom, they will cancel out. So there are no units associated with specific gravity because remember, it is a ratio. It is comparing two things, the density of a mineral to the density of water. All right, let's do some practice calculations now that we have our background information. Number 6 says a mineral has a mass of 29.97 grams and a volume of 3.7 milliliters. Calculate its specific gravity, then use data table 1, the metallic minerals identification key, in order to determine what mineral it is. We're going to write our final answers on the lines provided. Now, anytime we do a calculation in this class, we know we need to show our formula, we need to show our work, and we need a final answer with units. But we're lucky this time because specific gravity has no units. So to get specific gravity, we know we're going to have to find the density of the mineral. So we know that density equals mass divided by volume. If we go back and look, it has a mass of 29.97 grams. We're going to divide that by the volume of 3.7. So please pull out a calculator if you have not already. Put that in. What you should get is 8.1 grams per milliliter as the density. Now, we're not done. That gives us the density. We want specific gravity. So specific gravity equals the density of the mineral divided by the density of water. So the density of the mineral we just calculated, 8.1 grams per milliliter. The density of pure water at standard temperature and pressure is going to be 1. So our units cross out, and our final answer is 8.1. Our next step, it says to use the data table in order to identify what mineral has a specific gravity of 8.1. So here's our data table. Go ahead and take a look through. And what you should have found was cinnabar, the pretty red mineral. All right, let's look at number 7. A mineral has a mass of 18.17 grams and a volume of 7.9 milliliters. Calculate its specific gravity. Then use the data table, metallic minerals identification key, in order to determine what mineral it is, writing your final answers on the lines provided. So, same process that we went through before. Density equals mass divided by volume. The mineral has a mass of 18.17 grams. The mineral has a volume of 7.9 milliliters. Please plug that into your calculator and see what you get. 2.3 grams per milliliter. Are we done? No way. We only have the density. We want specific gravity. We know that is equal to the density of the mineral divided by the density of water. Yes, you have to do this step. So, density of the mineral was 2.3 grams per milliliter. Divided that by water, which is 1 gram per milliliter. Bam, bam, our units cross out. We are left with 2.3 as the specific gravity of our yet to be determined mineral. What do we do next? Take a look at your metallic minerals identification key and find which one has a specific gravity of 2.3. And what you should find is graphite. Now just keep in mind that this is the metallic minerals. There's also a non-metallic minerals key, which we're not using today, but we will in the future. And if you look, gypsum also has a specific gravity of 2.3. But our directions tell us that our mineral is metallic. And so we can identify it as graphite. Only one problem to go. Number 8. Looks like a doozy. All right. A graduated cylinder is filled with water to 22.5 milliliters. A mineral is carefully dropped into the graduated cylinder and the water level rises to 40.7 milliliters. And that is the water displacement method. You will be doing this with your lab. The mineral is then placed in a weighboat and placed on an electric scale. The combined mass is 72 grams. The weighboat alone has a mass of 2.8 grams. You will also be finding the mass of the mineral this way during your specific gravity lab. All right, calculate the specific gravity of the mineral. Then use the data table, metallic minerals identification key in order to determine what the mineral it is. Write your answers on the final lines. That should look familiar by now. This has many steps to it. We need to subtract to find the volume. We need to subtract to find the mass. Then we have to find the density, then the specific gravity. So let's start in the beginning. Water displacement is used to find the volume of an irregularly shaped object. We know that if we take the final volume of the water minus the initial volume of the water, that will give you the volume of the object. So, little review from previous units. The volume is going to be 40.7 milliliters, which is the final volume, right there, minus the initial volume, which was 22.5 milliliters, bam, right there. If you plug that into your calculator, you get 18.2 milliliters as the volume of the mineral. All right, let's figure out the mass of the mineral. All right, the mass with the weighboat, combined mass, is 72 grams. But that includes the weighboat, so we need to subtract out the mass of the weighboat, which was 2.8. So 72 minus 2.8 is going to give us 69.2 grams as the mass of the mineral. Now we can calculate density. Density is mass over volume. So our mass is 69.2 grams. Our volume is 18.2 milliliters. Please put that into your calculator, see what you get. Dun, 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 dun. 3.8 grams per mil. Are we done? No. Specific gravity is density of the mineral divided by density of water. So we have to take 3.8 grams per mil, divide that by the density of water, which is 1. Our units cancel out. Our ratio ends up being 3.8. So lots of steps, but we got a right answer. Let's compare that to our chart. Take a look. And what do we get? Limonite. And that concludes our specific gravity pre-lab. Bring this back on the due date, and you will be able to do the specific gravity lab in class with your lab partner.